Welcome to my presentation. Myself, M. Kalaiselvan, MS by Research, Department of Aerospace Engineering, Medchal Institute of Technology. My topic is design and development of multi-copter drone incorporation with the multispectral sensor for agriculture application. And first of all, thank you for accepting my paper. And I am giving the presentation for the same. So this is I am doing under the guidelines of Dr. K. Sendil Kumar, Director, Center for Aerospace Research, Madras Institute of Technology, Anna University. Now these are the subtopics we are going to cover in this presentation. So mainly the object of this projects and benefit of these projects, and design of UAV quadcopter, and what are the components used in the UAVs for data collecting, hardware and software we are using, and UAV data processing, how we done the process, and how come the data. So we'll see the conclusion and all. So abstract. In the modern days, the vegetation index and the crop and agriculture related all the things are UAV is mostly used because of it is a high, low cost and very high resolution map that can be generated using the drone. The previously we are using, the most of the things are using satellite based agriculture, crop monitoring, or some other land survey or something related to agriculture. But why these days are moved to agriculture is to the drone UAV mapping using multispectral or some other RGB camera like that. It is because of it is low cost and low time saving to the agriculture. So drone with the multispectral capture the unhealthy plant and monitor the health status of the crop field. The drone multispectral camera is used to whether it is unhealthy or healthy crop to the field area which we are covering. So that multispectral camera can be calibrated using the CRP, that is calibrated reflecting panel. That we are the multispectral has a 5-band on RGB, red, green, blue, and a near infrared and infrared. So those bands are calibrated to the reflection panel and taking the mapping whichever the field we are trying to observe, and then beyond that we are converting the output from that data to NDVA, SAVA, CVA, EVA, etc. So this will give the more accurate health of the monitor and health management. So with the less time we can cover the more data. So introduction. The unmanned aerial vehicle is deployed into the agriculture sector for improving productivity. How can be done using this? Because satellite data are always give the about 1 to 30 meter accuracy with a field view of 10 to 50 kilometer range. But in case of a drone, you can see the 0.5 to centimeter accuracy at the 5 to 500 meter. As of our test case, we are done with the 60 meter altitude at the ground resolution of 4 centimeter. So each pixel containing the 4 centimeter resolution. Unmanned aerial vehicle are being to prepare the source because of sort of advantage that you offer higher spatial time and time resolution, lower cost among the others. Why UAV for agriculture? Low cost, low level, centimeter resolution, detailed information, utilization, less time. So the main objective of the UAV is using if we get the more endurance of the UAV, we can cover the more area of agriculture field and find out the vegetation of the crop. We can save the more time. Designed UAV are introduced to agriculture field for the crop monitoring and health assessment. To capture the multispectral image to analyze the growth of the vegetation information of the crop field. So using the UAV mapping data, we can analyze and growth of the vegetation. So subjectives is identify and geotagged plant on particular area. Static analysis of the crop health status using various vegetation index. That various vegetation index is NDVA, SAVA, EVA, and CVA. Those are the indexation we are calculating using the toolbox. So benefit and outcome of these projects. The image and data allow for farmer to monitor, plan and manage the crop field for more efficiently. So using the drone data which we captured by the multispectral drone, which can analyze the crop health after the post processing data. So from that data we can analyze or monitor the plant So the management of the crop field is more efficient and with the less time. Save the time, money and provide on data. Reduce the framework in the crop field. So UAV application for the agriculture development, here we are mainly concentrating on the crop monitor and health assessment. Whereas other fields are crop description, crop spraying. So like that soil and field analysis, so much fields are using the drones. This is the UAV I am used to for the collecting the data on the field. So this is the Excite quad model multi-rotor UAV, which is used to agriculture platform for the capturing the field images. So the main advantage of the UAV is low cost, flexible, and it is a electric powered with the coaxial motor. So one arm containing each. It is used in the open source autopilot. The flight controller is Pixar and open source mission planner. This mission planner GCS ground control station. I am used for the planning the routes. The quadcopter specifications are model name is Excite rotor. That is Excite is the 8 rotor. Weight of the payload is without payload is 4 kg. The payload weight is about 150 gram. Here the payload is multispectral camera, which we showed here, and maximum flying height is 300 to 400 meter, and normal flight height is 35 minutes. Data radio range is 2.5, where the frequency which we are controlling the UAV is 2.4 GHz, that is free licensed version, and speed 30 to 60 km per hour. The center body of the structure is made up of carbon fiber and propellers. The propulsion system, the propellers are made in the carbon fiber. The autopilot is open source, but it is autopilot Pixar version. This is the workflow software and hardware platform. In case of the hardware, we are using the RGB camera and multispectral. In the software side, we are using the software image processing, orthomosic generation, and points cloud, and vegetation index calculation. So this is the camera we are used for the Mikasense Red Edge M. It is a 5-color multispectral camera designed for the precision agriculture. It has a 5-band, nearly blue, green, red edge and near red edge. Each camera has some nanometer wavelength. That is described by the 300 to 400 in the red, 400 to 500 in the blue, 500 to 600 in blue. If it is above 700 to 1300 is the nearly infrared camera, and above the 1300 nanometer is red edge. So this is the specification, and weight of the camera is 180 gram. So this is it is controlled by the Wi-Fi network, or it is an inbuilt GPS to give the geotagging of the each images. This is the workflow in the field. Fly using the multispectral camera, capture and process, analysis. The analysis are in the post processing, which will generate the RGB and NDVI and nearly red edge camera. So this is the creating the toolbox for the calculation of different vegetation index, which is come from the photo alignment of image structuring, that is dense point cloud and ortho generation. This is the sample area we collected in the Tamil Nadu Agriculture University, Coimbatore. The lat of the place is shown, and ground resolution of 4.9 centimeters. So that flight itself took 700 images. Mikasense Red Edge camera is used. Our overlap percentage is 75%. The mode of the camera trigger is timer mode, that is each some certain time it will trigger the camera. The flight altitude is 60 meter for the entire flight. So this is the UAV platform pattern. It should have a forward and side overlap, and the each image should be 70 to 60% to create a make better 3D model, orthophoto and digital elevation models. Without these criteria, we cannot get the accurate 3D elevation or orthophoto or digital elevation of the area. This is the raw images took out from the UAV. That orthomosic stitching. So after that stitching, point cloud generation, we are creating the various vegetation index using the toolbox which I have shown earlier. So image processing. In the image processing, we are creating the align photos based on the GCP. That geotagged photo also, it's keep calibrating the data, and after calibrating the data, it create a points cloud creation. After the point cloud creation, we get the orthomosic images like this. After this output, we can compare the satellite images and the UAV data. When you zoom the UAV data, we can get clear images, but not in the satellite images. It will get around 30 to 30-meter error, but here we can get up to centimeter level accuracy. These are the UAV images that has converted to the various output difference vegetation index, like I said, normalized difference vegetation index, enhanced vegetation index, and soil added vegetation index, like that. Here is the paper designed UAV and the multispectral sensor were performed for the collecting agriculture field data. In the short time, the remote sensing data can be achieved with a higher spatial image at 10 centimeter resolution compared to the satellite and land satellite images. So, as per the result, the UAV has been examined over a field, and the integration of the multispectral camera help us to monitor the crop. Once we get the NDVI output, we can get the and detect the analyze how the health of the crop and the unhealthy of the crop. We can get it easily with a lesser time compared to the other methods compared. The analyzed result and the data information represent an important source of farmers to make an appropriate decision to improve the quality and maintain management. So it will give the, I mean, farmer can easily can identify and increase the productivity of the crop using these methods. So thank you for everyone who contributing to do this work, and any suggestion and clarification are kindly welcome here. Thank you all.